Hi, everyone. Can you hear me all right? I guess you can. So first of all, props for staying here till the end. I thought this was going to be completely empty, but congrats to you and to me, I guess. So today, my name is Toma Puljak. Today, I'll take you through a deep dive into development environment configuration standards. So first, a bit about myself. I'm 23 and I've been active as a software developer for about 7 years now. I'm a software dev and advocate, or as my CEO likes to call me, the de facto DevRel of the company. I'm part of the core company team, and Daytona is a fresh startup. It basically wants to empower developers to focus on what matters most, and that's actually developing and not spending time on environment and toolchain configuration. Daytona offers SaaS and self-hosted development environments and wants to make the entire DevOps lifecycle as efficient as possible. Okay, so into the talk. So first we'll talk about what even is a development environment. Probably some of you know the answer, but some of you probably don't. So we'll reiterate on the idea. Then we'll see what even to standardize, because some of the things in your development environment are already standardized and some are not, and we'll see when and what to standardize. Then we'll take a deep dive into some of the most popular development environment standards, and to close it off, I'll show you how to choose the standard that will make your projects and yourself most efficient while developing, and that will boost your developer velocity to the max. So first, a concept that I want to introduce that will help us out through this journey is the inner versus outer loop, and it's a concept that's gaining more and more traction in the development world. So essentially, the inner loop is basically all you need to develop a project inside your development environment, and it includes your source code, project libraries, system-wide packages, maybe some external CLI tools, your personal customizations, and so on. The inner loop stops essentially when you push your code to Git. Then the outer loop starts. It includes CI processes, builds, packaging, and everything else. And the important difference is that the outer loop only needs essential tools to build the entire project. So no debuggers, no Git, no nothing, just your source code and the essential OS utilities. So let's get into what even is a development environment. So your development environment, of course, needs access to your code, your source repository. It needs to have access to pull and push from Git. That code has some project libraries like, I don't know, Lodash in Node.js or Entity Framework in C#. Then you need some system-wide packages, and that can be language runtimes, it can be Git, it can be curl, it can be any OS CLI tool, whatever. Then you need your ID to interact with all the code, and the ID might seem like a given, but it takes time to configure the ID exactly to your personal preferences, but to the project as well. I know, for example, I always forget which extensions to install for which project, how to configure them, and so on. And lastly, you need some compute resources as well. You need to have enough CPU, enough RAM to smoothly run the entire operation. So that's where standardized development environments come in, because none of us want to do this manually. None of us want to configure system-wide packages manually or ID and so on. None of us want to waste time on this process. Standardized development environments allow you to streamline all of this and never have to worry about any of the configuration. They just allow you to start coding right away. So now there's the question of what even to standardize in this entire development environment. And I'll assume that you use Git for your project, so your code and project libraries are already standardized by Git. So, for example, Node.js has Yarn and NPM to handle the package management of your code. Java has Maven or Gradle, C# has NuGet, and so on. That's already standardized. The hard part of the story is how to standardize system-wide packages, your ID, and the compute resources. Standardizing this part of the development process is what gives you the max developer velocity. It gives you the ability to ignore everything from the configuration aspect and just start coding. So, okay. I'll show you in this talk how to standardize all of this through code and what that brings to your workflow. And after this talk, you can think of development environments as code, essentially. The standards that we'll take a look in a short second will be defined as code, will be part of your source code and pushed to your Git repositories. So we can take this deep dive into one of the most popular standardization tools out there, and that's Docker. We can't really talk about standardization without mentioning it, and most of you here probably heard about it or are actively using Docker. And Docker is actually voted one of the most used tools in the Stack Overflow 2023 survey, and developers really love what Docker brings in terms of standardization. So you can even use Docker to create development environments, like this example here. So this Docker file doesn't have anything special, it just installs Git, Vim, and Node.js, and allows you to develop a Node.js app inside this container. What Docker, again, brings to the table is, again, no developers has to worry about installing Git, installing Node.js, installing Vim, sudo, and nothing like that. Just build a container and run your code inside the container. Of course, Docker has Docker Compose as well, because no project is sufficient to run on one service. You need a database, you need a cache store, and so on. So Docker Compose serves this purpose of you composing different services to run the entire project. And while Docker might be a great way to standardize your system-wide packages, what about the IDE and the compute resources part of the story? This is equally important as the system-wide packages, as installing the runtime, because it also takes time to configure. So that's where we'll take a look at a couple of standards that are also based on containers that allow you to solve these problems. So first is Dev Container. And Dev Container is managed by Microsoft. It's fully open source. You can go to GitHub right now, start it, and take a look at all of the tooling. It has a very comfortable CLI tool that handles all of the build process and starting, stopping the Dev Container. And it's, I think, one of the most popular configuration standards out there currently. This is an example JSON schema of defining a minimal Rust dev container. And as you can see, it's a very friendly JSON, developer-friendly JSON schema. Here we define a name like Rust Hello World. We point it to a Docker Compose file. And this section can be pointing to a Docker file. It can directly point to an image in a public or private registry. You can do whatever you want. Then you have a workspace folder, which basically defines where your code will be inside the container. And then the most interesting part is the post create command, at least for me. This command will execute when the dev container is built, and it allows you to, again, streamline the installation of packages. So for example, when the container is built, it will execute cargo install and automatically install all the cargo packages inside this container. Again, one thing less to worry about in the entire process. And lastly, we have a remote user, Daytona. In this case, it just defines what user will be using the shell once you enter the container. Another great thing about dev containers is that you can directly write your customizations for the ID inside the config file. In this case, we write some settings and extensions for VS Code that are available right when you enter the editor. So for example, we set up some Rust-specific settings. We say to the VS Code, download the GitLens extension, and when you enter the ID, the extension will be waiting for you. The settings will be configured, and you don't have to tell your other devs in the team how to configure them. What's great about customizations in dev containers as well is that you can define them based on where you're working. So, for example, you're working in browser VS Code, desktop VS Code, any JetBrains IDs. All of these customizations can be different inside the one configuration file. Also, another important feature of dev containers is called features. And features allow you to extend on the capabilities of the base container. So, for example, we have two features here, and you basically point where the feature is being hosted. In this case, it's publicly hosted. And you tell which feature you want installed, in this case, common utilities, and you say, I want ZSH installed, I want the username Daytona configured, and I want you to upgrade all the OS packages immediately. Then we have the Rust feature, which essentially just downloads Rust and to the latest version inside the container. Features are great because they really allow you to extend the dev container, and there's a massive, truly massive list of publicly available open source features. And to write the feature, it's really simple. If you look at a spec, it's just a single script with some arguments that you define and push it to your private, public registries wherever, essentially. And last thing I want to talk about the spec of dev container is the host requirements. Host requirements allow you to say, I want my development container to have at least 2 CPU, at least 4 gigabytes of memory, at least 32 gigs of storage, and a GPU. Host requirements are what ties the dev container all together. They allow you to have a smooth experience while developing the project. In this case, this could be some host requirements for, I don't know, an AI project that requires a GPU. You can do whatever you want and tell the dev container how much resources you need to run your project. Another awesome thing about dev containers is the IDE integrations themselves. Because it's managed by Microsoft, of course, they have a great integration with VS Code via an editor extension. So you just open the IDE, open the command palette, type in reopen in container, and that's it. Once you type the command, you can instantly start coding inside the dev container once it's built, of course. When the dev container is built, you'll see a list of dev containers who you can get the logs, get the details, start them, stop them, whatever. Think Docker containers, pretty similar. But also the additional feature of attaching your VS Code directly inside the container. So you can choose to work in your, I don't know, Rust container. You can choose to work inside your database container. You can choose whichever dev container you want to work in instantly. And of course, for the JetBrains lovers, there's a JetBrains extension as well that works in any JetBrains IDEs. It gives you a simple interface to create a dev container when you select the dev container JSON file. It's really simple, it's really intuitive, and it works great in both IDEs, or I should say, like 11 IDEs of JetBrains. So that's dev containers. They are fully open source, container based, have excellent IDE integrations, and are really developer friendly, and the schema is really easy to pick up. There's also an abundance of resources online. There's already open source projects implementing dev containers, so you can try them out locally in VS Code right away. Okay, so now let's take a look at a second standard, and that's devfile or devfile.io. Devfile is managed by the Cloud Native Computing Foundation, which manages a lot of cloud native open source repositories like Kubernetes, for example. And the devfile specification is based on YAML. And I don't know about you, but I really dislike YAML on a core level. I don't know why, but I just do. I tend to like simplify the whole YAML structure to myself. And this, for example, this devfile.io specification will create what? Will create a Go container that will have the latest Go image from some repository. And once this dev file is built, it will have a Go runtime, and you are sure that the Go project will run inside this container. If you look at the definition of dev file, you will see that they declare themselves as a Kube native API for cloud native workspaces. What that means is that they are heavily tied to Kubernetes. And devfile is a tool that will cater towards the Kubernetes followers and developers out there. Also, because devfile is open source and because it's managed by CNCF, they heavily advocate its ecosystem. So they want you to write dev files, they want you to publish them to public registries, to private registries, wherever, and then consume them from them. This gives you a huge ecosystem of already available dev files that you can then refer to as parents. So in this case, we refer to a Node.js dev file as a parent from this registry URL at a specific version. This gives us the ability to extend upon this dev file and add additional features or just use it as is. Use this inside your project and you will have a Node.js container and a Node.js development environment right out of the box. Another great dev file tool is called Odo, and Odo is the de facto CLI tool for dev files. Odo is great because it leans into the inner and outer loop story natively. So, for example, you can use the Odo dev command to launch the container in development mode and develop your application, debug the application inside the container natively. Then when you're done, you just use the Odo deploy command, and the Odo deploy command takes care of the outer loop part of the story. It deploys your application inside Kubernetes as you defined it in the standard itself. You can also deploy it to OpenShift, which I'll tell you more about later. And again, you can use the OpenShift toolkit inside VS Code and inside JetBrains, which is an IDE extension. you can use it to create dev files based on your source code repository. The odo init command will automatically initialize a dev file specification file according to what it scans inside your repositories. Then you can manage your Kubernetes, you can manage your registries, and also create or destroy your dev file containers. And as well, it's available in any JetBrains IDEs, so the integration really for odo is spot on, or should I say for the OpenShift toolkit. Dev file as well, as I mentioned, is catered towards the Kubernetes lovers. Why? Because you can define Kubernetes manifests directly in the file. So in this case, for example, we defined we want a component called my K8s deployment. Then we inline the exact Kubernetes manifest we want deployed in Kubernetes when using the dev file. So in this case, it's some job with a couple containers and a restart policy never. This gives you the flexibility to exactly manage and control everything about the Kubernetes containers that dev file will spin up. Dev file IO is actually natively supported in Eclipse Che inside OpenShift, and you can use them today to spin up cloud native workspaces basically right now. So dev file and odo are fully open source, are kube native, which means most of you using here Kubernetes will cater towards dev file. They heavily rely on their ecosystem and allow you to publish your dev files for further extending or use publicly available dev files. And they lean towards the inner and outer loop story by design. Odo by design has the odo dev and odo deploy and allow you to manage both parts of the story. And now, the last standard I want to talk about today is something that's completely on the other end of the spectrum, and that's Nix. Nix is not container-based. It's not heavily reliant on Kubernetes. It can run on virtually any platform, Linux. I don't know about Windows, but probably on Mac. Wherever Nix runs, it will run automatically. So Nix is a purely functional package manager, which means that it treats packages as values in purely functional languages like Haskell. What that means is that any package that is, once it's built, it can never be changed. Packages, if you look at the definition or a directory of a package, has some hash and then the name of the package. And this hash is a cryptographic hash of the dependency graph of that specific package. What this means, there's a lot of fancy words when it comes to Nix. What this means is that if a single dependency of a single package changes, you get a completely different package. That means that all the packages are built in isolation. All the packages have all the dependencies needed for it to run on any platform. When you install a Nix package, you can be sure that it will essentially never fail because it has everything it needs for its runtime at all moments. Also with Nix, you can create what they call ad hoc shell environments. In this case, we create a Nix shell with Git, NeoVim, and Node.js installed. The Nix shell allow you to test out your code before deploying it to a certain environment. For example, I want a Node.js, I'm running Node.js 18. I tested the code, it works in 18, that's fine. And then I want to upgrade to 20. You can just launch a Nix shell with Node.js 20 and test your code without modifying any of your existing code, any of your existing environment locally. That's what Nix shell does. But even though Nix shell is great for testing out your code and for developing, it's not really a standard in and of itself. But that's where the shell.nix file comes into play. And the shell.nix file allows you to declaratively define all the packages of your environment, all the system-wide packages that you need. In this case, it's a minimal example. Again, it's Node 20, it's Yarn and Git, and this Nix file will launch a shell every time exactly the same on each platform where Nix runs. You will get the exact same environment. I'm not going to talk more about the Nix language itself, but you should take a look at their docs. They're really extensive. You can do essentially whatever you want with Nix. I'll stop right here because there's a lot more to talk about. And Nix by itself is a development standard, but there's something more that pushes this to the next level. And that's, oh, sorry. One more thing before I push this to the next level. That's composing shared configurations. So what I wanted to talk about here is reusing Nix files from your different projects, from, again, open source projects, from private source projects. You can for example, centrally manage all your shell environments inside a single repo and then import them in different projects, so you can be sure always that you have a working Nix shell environment inside your project. And now on to the next level. So the next level is NixOS, and NixOS is essentially an OS level of purity. So NixOS is based on Nix, and everything inside the OS is managed as configuration files. What this means is, for example, this is a standardized and reproducible OS configuration. You define the bootloader, you define the file system, you define that SSHD will start, you define which packages to install, you define how they're installed, and NixOS ensures that when you run it, it works on every platform. Additionally, what this means is that it's completely immutable and secure. It's more secure than Linux in a sense that to insert a malicious package, to insert a malicious service, you need to first modify the Nix definition files, then reload the entire OS, and then the user will get some malware. So imagine yourself working and something malicious needs to be inserted. You will get a bootloader because the OS is going into the rebuild state, and you didn't touch anything. That essentially would mean that something is corrupted. But NixOS prevents this because everything you need, everything that needs to be inside the OS is defined as these Nix files. Additionally, there's no fear of disconnecting during an update, no fear of when Windows is loading, you have to stay on power, you have to stay online. If Nix OS upgrade fails, it will just roll back to the last usable state, to the last consistent state. This means easy rollbacks. When Nix rebuilds, it stores the last state as files on your system as well. So if you want to roll back to version, I don't know, 1.0, you just do Nix rebuild switch rollback, and instantly you're transported into the last version of Nix. So that was Nix and NixOS. NixOS is fully open source again. It's a functional package manager that ensures consistency across all the environments where Nix runs. It's a fully secure OS that is immutable and completely controlled by you, by your configuration files. And the atomic upgrades allow you to always end up in a consistent state, always end up in a usable state, and it prevents any failures during the update. So the last question and the last topic to talk about is between these three standards, or any standards that you come across, how to choose one that boosts your velocity, that works with your project perfectly. So this, for example, is a table that I drew up for this talk. It can be any table that you want. You can compare anything in these number of standards. So for example, if your application is already containerized, it would be easy to implement dev containers or dev files. If you want great ID integrations, you can get, again, dev container or dev file. If you want something Kubernetes-based because your team works with Kubernetes, or you want to get hands-on and dirty and define exactly how your resources are managed, then choose dev files. If you want OS-level security for your entire team, if you want to always be sure that everything works on an OS level, then Nix might be the way to go. But my last parting thought is choose whatever you want. It doesn't really matter which standard you choose to implement. What matters is that you understand the benefits, you understand what the standard brings in terms of velocity. You understand that when you implement the standard, there's no hassle of setting up the environment. When you onboard a new person to the project, to the company, you don't have to spend a week with them setting up their laptop. You just give them the definition and the environment, and that's it. And of course, Daytona supports all of this. A short plug, I'm sure. So Daytona allows you to really create these development environments with these definition files. And we really want to advocate this new workflow where you don't worry about any of the configuration, just commit a standard and that's it, work out of the box. And Daytona as a platform also can be deployed in your company infrastructure. It's not the only tool that does this. Deploy it securely, control all your resources, and be finally free from all of this fuss with development environment setup. And that's it. Thank you for holding on till the last talk, and I really appreciate it.